Using the rational roots theorem to find all zeros of a polynomial, or irrational zeros. I think I may have said rational roots theorem. You could also call it the rational zeros theorem. Let's list the possible rational roots. Possible. We don't know, but the rational roots theorem just says possible rational roots would have the form plus or minus factors of 5 over plus or minus factors of 2. So what do these really look like? Let's see. Well, we could have -5. We could have -5 halves. We could have -2. We could have -1/2. What else could we have? Certainly could have +1/2. I forgot -1, so we could have -1 as well. -1/2, +1/2, then 1, then what? 2, then 5 halves, and then 5. So we have all these options, and we're just going to do trial and check with synthetic division. Let's see, why don't we try, let's try -2. I'm going to put -2 here. I need the coefficients 2, 10, -3, -14, 5. Now we're going to bring down the 2, and now we're just going to multiply and add. 2 times -2. 2 times -2 is -4. Add it to 10, we get 6. So we keep writing. 6. Then we repeat. 6 times -2 is -12. Add it to -3, we get -15. -15 multiplied to -2, we get 30. 30 added to -14, so we got 16. And notice this isn't good. We don't get 0 as a remainder. So -2 doesn't work. Why don't we try -1? We try a smaller number. Bring down to 2. Multiply and add. 8. -11. -3. And we have an 8 here. That's once again no good. Let's try something else. Why don't we try, we could try 2, I guess. 2, 14. Ooh, 28 plus 3, 25. Oh, this is getting pretty big. 36. That's no good. So, why don't we try -5? -5. Bring down to 2. 0. Well, this is -3. Add 15. We get 1. Aha! We got a remainder of 0. We're in good shape now. What does this mean? That means we want to find all the zeros. First of all, to find all the zeros, we need the output y to be 0. So we have 0 here is now equal to, we have one of the factors. It's actually x plus 5. And this right here, since we divided by x plus 5, we have a remainder, we have a remaining polynomial of degree 3. 2x cubed minus 0x squared minus 3x plus 1. And we could apply synthetic division again. We're going to apply synthetic division to this polynomial, 2x cubed minus 3x plus 1. So what are the possible rational roots? Well, we could have -1, -1/2, We could also have 1/2. And we could have 1. Let's try, looks like 1's going to work. So if you look at this, 1's going to work. Bring down the 2, multiply and add. Multiply and add again, we get 0. Ah, that's gorgeous. What does this translate to? This translates to 2x cubed minus 3x plus 1. Now factors to what? Factors to x minus 1, and what do we have left? 2x squared minus an x. Yeah. All right. Why don't we try that? 0 is now equal to x plus 5. Now we have an x minus 1. And then what is left? We have a 2x squared minus x. Something doesn't seem right. This doesn't seem to check. There are no constants here, and I want a constant of plus 1. Let me think about this for a sec. I see my mistake. This doesn't seem to check, and that is because I forgot to put a placeholder. So we're right about here. Let me go back and erase some of this. Let's erase this. This isn't right. This isn't right either. Those are not the true factors. Let's try this again. Let's put the placeholder in and see what happens. So we have a 2. We have a 0x squared. We have a negative 3 in front of the x. And we have 1. Let's try this again. Let's bring down a 2. Multiply and add. And we get a negative 1. And now we get a 0. This is better. What does this mean? This means that we have an x minus 1 down here. And what do we have left? We have a 2x squared plus 2x minus 1. And we're in good shape here. We're almost done. We need to find the exact values of the zeros. So we got 2 of them. Now we need the third one. Let's go off to the side here and show some detailed work. I'm going to take this quadratic and we want to set this equal to 0. Right? Because, I mean, the very next step, I mean, you're going to write x plus 5 is equal to 0, or what? X minus 1 is equal to 0, or what? 2x squared plus 2x minus 1 is equal to 0. Let's use the quadratic formula because this doesn't factor. So we have x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Not a problem. X is equal to the opposite of b plus or minus the square root quantity 2 squared minus 4 times 2 times negative 1 all over 2 times 2. Let's simplify this. Here we go. X is equal to negative 2 plus or minus. We have 4 plus 8. What's 4 plus 8? 4 plus 8 is 12. There's a perfect square in 12. It is actually 4, so we have 2 root 3. And then we have a common factor down below of 2. We'll leave that as 2 times 2. Let's reduce. Let's factor out a 2. And let's see what's left. Negative 1 plus or minus root 3 and over a common factor of 2, and then we have that left over. 2 over 2 is 1, and I think we have all the zeros. Let's write all the zeros here. X is equal to negative 5. X is equal to 1. That's another 0. We have x is equal to negative 1 plus or minus root 3 over 2. So 4 zeros altogether. We could circle our answer now, and we are in good shape.